Hello, everyone. Welcome to another episode of Pints with Ayre. I'm Brent Heffley, the Sales and Marketing Director for Ayre Acoustics. I'm here with Ariel Brown, our Senior Engineer and VP, and Ryan Berry, our CEO and Expert Technician. It's a cold, wintry day here. I don't know about you guys, but in Eugene, the temperature dropped this morning, and it was time to break out some dark beer for pints this afternoon. So I don't think it gets too much darker than that one. It's from our local place, Oakshire, which, if you remember, with the episode with John Atkinson, I believe I had one from them called the Ill-Tempered Gnome. Mm-hmm. This time it's the Overcast Espresso Stout, which is one of those things that'll get you through the winter days, both with the espresso and with the stout part. So it's the perfect mid-afternoon beer. So I know it's not quite as cold there. What did you guys dig out today, Ariel?
So I ventured just barely outside Colorado, Wyoming Brewing, Melvin Brewing.
Oh yeah,
that my brother likes quite a bit. This is the Killer Bees American Blonde.
All right.
Light.
Killer Bees. It's what you need once you've been stung a few times by
something like that.
And I got to say, the honey in this one actually really comes out well.
It's nice.
Nice. That's cool. That's cool. Well, cheers everyone out there. I hope you've got a good pint and are ready for a good episode. Today we're going to talk about our first patent. The one that we just finished getting approved, filed a couple of years ago. It's a long process that, Ryan, you did the bulk of getting through all of that. And
yeah, what was that, a 3-4 year process?
It seemed to take a while.
Mm-hmm.
But it has to do with SPDIF and how you transfer digital data and how we have figured out a better way to do it. So with that brief introduction, Ariel, do you want to talk about what SPDIF is, just to give everyone kind of a basic intro? And
sure. Yeah. So SPDIF stands for Sony Philips Digital Interface. And so it was kind of a joint kind of project with those two companies to have kind of a standardized, what we consider a single wire interface to transmit digital audio data. And so with a single wire, what that means is that any kind of clock information is embedded in the signal. And so so the bit clock, word clock is combined within the actual data. And so there's the actual data transitions happen at certain times. So whether it's a low to high or a high to low happen at certain times. And there's a couple of violations of that, which is how you then sync the word clock. And then with the actual usual transitions within each bit, you can then try to extract the bit clock. And so it's what's a common problem with that is you can actually get some data related jitter components when you extract that clock, because it's not extracting that clock is not a perfect process, because it's you're trying to filter out the data from that data stream to actually try and get that clock out.
Right.
So and then depending on the data density or what particular signal is being sent right then, it can actually slightly affect the clock that you recover. But it's a very simple and standardized format, so it's very popular.
And it's used on a lot of stuff, like we see it coming out of TVs, out of Xboxes, out of computers.
Right, and it comes in various forms. Like the standard SPDIF that's either on an RCA or on a BNC. The BNC is more officially, the proper impedance, 75 ohm impedance of a true SPDIF interface. RCAs are a bit more common. They don't really hold that 75 ohm spec very well. But even things like Toslink is also just just an optical version of SPDIF. It's still SPDIF.
Right. So you've got the optical that's SPDIF. You know, if you look at the back of a QX5, for example, you've got the optical inputs that are SPDIF. You've got the BNC connectors that are SPDIF, and then you also have the AES EBU, and that's similar.
Yeah. So it's still the same basic interface. But then it is then a balanced configuration of it.
Right.
So that there's two low voltage differential signals, but it's the same format. There's also within the clock and the data. There's within some of the extra bits that actually embed some more bits that that you can pull out and parse into this basic data block that gives you information like sample rate, or tell you like what the source was and time information. And there's a lot of user bits that can be transmitted from that. And so there's two actual variations on. There's a consumer standard and the professional standard.
Right.
The actual data and clock stream is still the same. The only difference between them really is just the definition of those data bits that you extract separately just have slightly different meanings in the consumer and professional standard. But otherwise, they're completely compatible. AES, EBU, SPDIF, the Toslink, they still use the same system.
All right. And then, you know, they've been used a lot, and, you know, I think they are kind of in the high-end audio world regarded as kind of like the least common denominator, like the lowest version of transmitting a digital signal.
Well, I mean, I guess that depends on who you ask.
Yeah, true. I guess so.
We released the QB9 years ago, and you know, it was a USB only DAC, and I remember there's quite a few people that were not pleased that we didn't have an SPDIF input on the thing. And you know, it was the same discussion then that we, you know, had later. Is you know, the problem is that the SPDIF, in our opinion, just with the jitter component of it and everything else, it was not as good of a standard as even USB at the time. You know, it wasn't that USB was the best standard in the world. It's just it was the best standard available. So that's where the QB9 became USB. We could do that asynchronous and have a lot of advantages there, and to eliminate the jitter on the USB input. But we didn't have such a mechanism in the SPDIF standard.
Right. So is that partly where the inspiration came from, Ariel, was with the asynchronous USB that we used to try to make something that would work with SPDIF, or was it from some other place?
No. I mean, that's really kind of a separate case. You know, there have been many, many audiophile companies have had various solutions to try and address the jitter problem of SPDIF. You know, either with much more complicated PLL filters trying to extract that clock better and better, to various buffering schemes, and again, you know, buffering so that you can manipulate the clock in the end to be able to get the to be able to clock the data out of a buffer at using a cleaner clock. And so for years, we wanted to make a DAC for a long time, but we never had what we thought was a good solution to that jitter problem with SPDIF. And when we did the QB9, I mean, we still didn't have a solution, and the USB asynchronous USB provided us with a true jitter-free interface that we were willing to make a true high-end DAC with. But so with our async SPDIF, we came up with a way to deliver the transmitted data to our DAC, to the actual DAC chip, with a jitter-free clock. Well, there's always some degree of jitter, but again, like with our own master clock. And so It does use a buffer scheme. So we have a large memory buffer that clocks in the data using the recovered clock of the SPDIF system. But then we use a clock that is guaranteed slightly offset from the incoming clock, so that we are always filling the buffer. It is never empty. It's guaranteed to never be empty. So then we can have our own completely separate master clock that clocks data out of that buffer at our master clock rate, which is the best clock that we can design with the lowest jitter possible, given that implementation for that level of product. Right. So it completely isolates the two clock domains.
That's super cool.
Yeah, and I mean, the way to think about that is, you think about where that clock is placed, in a more traditional standard without any, type of treatment. You have your clock coming from the device that's sending all the signal. And that's far, far removed. Whereas, we can now have a clock that is, millimeters or centimeters or whatever the placement is away from the DAC, and you minimize that path as much as possible. So you gain a lot of advantages there.
Right. Yeah. Right. And so, it's, that sounds really simple, but there's a lot of problems that crop up when you actually.
So easy that nobody's done it before.
Right. Yeah, because you can't just you can't keep filling the buffer indefinitely. It will eventually overflow.
Right.
And then you lose data. And so we had to come up with some sophisticated memory recovery schemes. And so, and that's part of the secret sauce in doing it, so that it is usable and it feels very seamless in the way that it works. Obviously, if you've used either QX5 or the QX8 or any of our new products that actually use this, it doesn't work great with a video source. And so we have a video option mode, and in that mode, it does use the recovered clock in that mode because it needs to stay in sync with the video. And the asynchronous solution that we write does not stay perfectly synchronous, and it will lose more sync over time.
Right. And that's great that we have that option in there. You can go into the menu on either of those products and choose music or video mode for that particular input. So if you've got one SPDIF coming out of your TV or out of something with video, then you can set it for that. If you got another one that you're just using for music, you leave it on the music mode and it operates asynchronously. So,
right. And we have, we haven't just thrown that, we still make sure to pay attention to that recovered clock and do that as best as we can.
Uh-huh.
We don't just throw it under the bus and just let us. So that
matters. Everything matters.
Right. So the video mode still sounds quite good. I mean, I'm not giving away everything.
Yeah. But there is a difference between the two, and you can definitely hear it. That's the big thing. I remember after we had finally got the QX5 doing it, I think that was the first product that we did this with. Charlie had come in, and we had the DX5, which was an older product of ours, hooked up to the QX5 via the AES EBU.
Right.
And plugging in SPDIF into that unit. And he came in and he sat down. He sat there for about 3 or 4 minutes and was listening to a song. And then he said, "Okay, stop it." And we stopped. He goes, "This is the best I've ever heard the system sound." And it was like, well, that made you feel really good because, you took a product that was, the DX5 was no slouch. That, as you guys know, we did the DSD upgrade on that. It had quite the improvement in its DAC. So it was not an outdated product at that point in time. It was only, about 3 or 4 years old at that point. And then the QX5 comes along and plugged that into that, and it blew his mind how much better it sounds. So, for us, being the type of people that like to think of ourselves as customers as much as designers, it was cool because you'd have now this QX5 that could upgrade every product in your system essentially if there's a digital output on it. So, you know, you could upgrade everything, worry about one box. Anytime that there's an analog improvement, you just upgrade the QX5. You don't have to worry about this CD player and this DAC and this Blu-ray player and everything else that you might have hooked up in it. You get to do it all in one piece.
Right. Right.
Yeah.
And then the other big thing this addresses is that you know with the original SPDIF standard, you know the quality of your recovered clock, you know was very dependent on both the quality of the transmitter of your source and of the cable used to get it to the DAC, and so in theory and in practice, as we've experienced so far, is that now all those variables as far as the cable, the source, are completely removed. With that buffering and the complete separation of the clock domain, those factors do not affect the result anymore.
Wow, that's yeah, that's great, because there's a lot of you know, often a lot of products you want to plug in would want to plug into the QX5 or QX8, but that's the only option you have. You know, there's not really that many things you can plug in with a asynchronous USB,
right,
or Ethernet, right? Like, so that's,
yeah, I mean, that's the limitation.
Really,
you're not going to be able to hook up your you know, Blu-ray player that's, you know, from, you know, whoever, big box company, into a USB input into a DAC. So, you know, you are very limited on what you can hook it up to. It has to be a full server that can host USB and everything.
Yeah. Yeah. Fantastic. Well, I think it's super exciting that we have that now. And, you know, I don't know how many people are out there just waiting for that to happen, but it's, you know, when you do get a QX5 or QX8, right, then you've got that option. You just know, oh yeah, I can just plug my DVD player into this and I know it's going to sound good, you know, better on music and music mode. Or a CD player that you have, or you know, some type of other streaming unit if you have something extra at your house that you know, that you want to use. You've got a lot of different options, which is the goal of the QX5 to begin with. It's the digital hub.
Absolutely.
So great. Well, thanks, Ariel, for designing that. Thanks, Ryan, for plowing through all the paperwork and red tape to make it happen.
Well, one other thing we should mention, Brent, is, you know, the QX5 is not the sole owner of this technology either. You know, this is something that's moved on to the QX8. The EX8 has this as well. So this is, you know, part of our philosophy is we don't like to go backwards. So we try to implement a version of everything that we learn in every product that comes out, and that's going to continue on for us. So whether it be a higher end or whether it be a more affordable end, we do everything we can to try to incorporate those technologies into all of our products. Yep.
Yeah, it's great. It's another item that we can put into everything that we'll make.
Yep, absolutely.
All right. Well, if you guys have questions out there, email us, Pints at Ayre. We'll answer them, or at least do our best to come up with something. If there's something you want us to address in another episode,
come up with something.
We'll come up with something.
We'll come up with something. Answer for you.
That's my specialty. We'll come up with something. All right. Well, until next time, cheers and happy listening.
Cheers.